charged tapes by Karthik Chilukapati. So the introduction, the purpose of this lab is that we are trying to find the amount of charge on two pieces of clear tape that we charged by ripping off of a table. And the fundamental physics principles we're going to need for this lab are E equals KQ1 over R squared, and electric force, which is Q2 times the electric field. Q1 and Q2 are basically the charges of our two objects that we see. K is a constant and R is the distance between them. And then we have F equals ma, which is our general force principle. Preview the results, we see that the tapes repel each other and were positively charged, and we will see how this happens later in this presentation. So our initial conditions, we have our system being tape piece B and the surroundings being tape piece A. As you can see in this diagram, this is how we set up our experiment after charging the two tapes to basically see how they react when brought close to each other. Initial conditions, the mass of each tape was about 1.7 times 10 to the negative 4 kilograms. We made the length of the tape standardized, making it 0.2 meters or 20 centimeters, and the width of the tape is 0.02 meters. In the lab, we had 7.1 and 7.2 questions. So for 7.1, it asked for our expectations, and I was expecting both of them to repel because if they both ripped off the table, I feel that they would have the same charge. It's just that I don't know if they're positive or negative at this moment. And 7.2 questions were asking what happens if the positively charged tape, if the tape was positively charged and it was brought to the negatively charged plastic pen. I said they would attract because one is positive and negative. If the tape was negative, they both would repel, and if the tape was neutral, the tape will still attract to the pen to transfer electrons to balance the charges. Experimental data, this is where we actually did our physical experiment. Once we made our charged U tapes and brought them close together, we saw that the pieces themselves repelled from each other, meaning they both had the same type of charge, which is either positive or negative. But later on, when we charged a pen and made it negatively charged and we brought a piece of tape close to it, we saw that the tape was attracted to the pen. So in order for attraction to happen to the negative pen, the tape would have to have a positive charge on it. So that means both the tapes had a positive charge. Going to the computational data, we tried finding out what the charge was on each tape and the ratio between electrons to the atoms. And over here we can see our code that we set up. We just have the charge of an electron, the tape's mass, length, width, constants like gravity, the distance, the length of an atom, and our scale factor we use to see our diagram. And here we calculated our force, gravity, and force, our electric force, to find our total forces acting on our system. And we found a charge by using this equation. And in the end, we found that the tape charge was about 1.32 times 10 to the negative 8 coulombs. And then we also just found some other information here. Here at the bottom, we created arrows and spheres to create this diagram of our system and show the forces acting on it and the direction that they're acting on. So for example, this upper arrow is our electric force and the bottom arrow is force gravity. Moving on to discussion, since both of our final result was that the charge of the tapes are positive and that we found that this was happening but we found out this was true because we had a negatively charged pen and both of the tapes were attracted to this pen, meaning that the tapes had to be positive and that they both repelled each other. So that means they both are the same type of charge, which is positive. There could have been some errors in this lab because we were dealing with the U tapes with our hands. So even though we try to maintain minimal contact with the tape, there is still a possibility that some of the charge was transferred to our hands, which altered the overall effectiveness of how charged these tapes were. And the lengths measured in this experiment, such as the width of the tape and the length of the tape and the mass, could all be obviously a little not exact because they could be prone to human error. And our what if and what does it mean questions. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? I would say nothing would change because it would just be the same scenario but flipped around, and the result on which they repel or attract will stay the same. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Well, the charges can transfer between your hands and the tape because if it's coming in contact, we can have a transfer of electrons between the two systems. But this could cause the overall charge to become less positive on the tapes, which would obviously alter our experiment and make it ineffective. This was tried to be done at a minimal extent, but this could also be an error in the experiment.